Consider yourself right now to be at home sitting on a chair. You probably feel quite still as you sit back and watch this. But how fast are you actually moving? Well, to truly establish this, there are several factors that need to be considered. Number 1, the Earth wobbles on its polar axis. This motion is not exactly relevant to the calculations that may be needed to, say, return to Earth from interstellar space, as it is an in situ motion, but it exists nonetheless, so it must be considered. Number 2, the Earth also spins on its axis. For these calculations, we will use the equator with a circumference of approximately 25,000 miles. One rotation of the Earth is approximately 24 hours. Again, this is an in situ motion and is not relevant to space travel, but it adds to our stationary chair model. A 25,000 mile rotation in 24 hours means that if you were standing at a fixed point above the Earth looking at the ground would be moving beneath your feet at 1041.7 miles per hour. Number 3, the Earth is orbiting the Sun once a year. The circumference of the Earth's orbit is approximately 607.6 million miles, or 940 million kilometers. 1 year is approximately 365 days. 365 days times 24 equals 8,760 hours. 607.6 million miles divided by 8,760 equals 69,360.73 miles per hour. So far we have basically 3 directions of motion. We have wobble, we have spin, and we have orbit. And we have a combined speed of 1,041.7 plus 69,360.73 for a total of 70,402.3 miles per hour for a person sitting in a chair at the equator. Getting dizzy yet, folks? Perhaps experiencing a little motion sickness? Well, here's why. When you take into account the 3-dimensional picture of the Sun's movement through our Milky Way, things begin to get a little complicated. For number 4, the Sun, and hence the entire solar system, is actually drifting towards the constellation of Hercules, namely to the star Lambda Herculis at approximately 12 miles per second, or 20 kilometers per second, which is 43,200 miles per hour. And for number 5, we must take into account that the solar system is also moving upwards at 90 degrees to the plane of the Milky Way at 4.34 miles per second, or 15,624 miles per hour. Number 6, the solar system is orbiting around the galaxy at an estimated speed of 124 miles per second, or 200 kilometers per second, which is 446,400 miles per hour. And were we an astronaut, this is where finding our way home becomes a little difficult, as we do not have an actual true figure for this calculation. The further out we go, taking into account the various motions and speed, the more difficult it becomes to get precise calculations, ergo the more room for error. Until we can actually go out and measure these distances, a best guess is all we have. Over the past few decades, these values have been revised several times and are constantly being added to today. Now, from an astronomer's point of view, this is not a problem, as astronomers are merely observing from the Earth and can fix their calculations when they get new data. No harm done. They just reprint the maps. But from a spaceship pilot's point of view, touring just within our own galaxy, the problems are enormous. So, from a navigator's point of view, we can leave out the wobble and the Earth's rotation as those movements are in place. For latter calculations, we could also leave out the Earth orbiting the Sun, because if we can make it back to our own Sun, then I'm sure we can locate the Earth. So just within our galaxy, our armchair astronaut is now moving in 6 different directions. And we have 69,361 miles per hour for spin and orbit. We have 43,200 miles per hour drifting towards Lambda Herculis. We have 15,624 miles per hour perpendicular to the galactic plane, and we have 446,400 miles per hour orbiting the galactic center, or the galactic spin rate. So we find our armchair astronaut moving at a combined speed of 574,585 miles per hour. So if you were to step off the planet and simply stand in space, you would find that for every hour you are away from the planet is moving over 500,000 miles away from you in several directions. Now, if you were to leave the galaxy and simply stand at a fixed point in the universe, you need to add another 1,339,200 miles per hour to the calculations, as this is the speed that the galaxy is moving through the universe. But then you tend to get into severe difficulties attempting to pinpoint your reference point. But nonetheless, what we find when taking all the calculations into account is that our armchair astronaut, namely you as you sit here and listen to this right now, is actually moving through the universe at a combined speed of 1,913,785 miles per hour in 7 different directions. So you see, if we were to develop interstellar space travel, the propulsion unit is actually the least of your worries, because what you're going to need to do anything is a really, really good navigator.